Hello, welcome to Chemistry with Mr. Olson. We're going to do some stoichiometry. So let's see. Oh, how lovely. All right, question number 4 on the back of the basic stoichiometry worksheet. Here you see we've got our framework, grams to moles to moles to grams, or grams of X to moles of X to moles of Y to grams of Y. And we are going to do some of those problems. But to go from moles of one thing to moles of another, we need the balanced chemical equation. Let's translate this English sentence into a balanced equation. Solid magnesium oxide, that's MgO. So here we go. MgO says plus reacts with liquid water, that's the other reactant, water, H2O, to produce, that's the product, so we need an arrow, magnesium hydroxide. Let's see. So magnesium is a +2 ion, and hydroxide is -1. We leave space for the coefficient, Mg +2, and so we need 2 hydroxides, OH2. There we go. And it's already balanced. Magnesium, 2 oxygens, 2 hydrogens. Magnesium, 2 oxygens, 2 hydrogens. It's balanced. So unfortunately we have very boring coefficients, 1, 1, and 1. But let's go ahead and do a problem or two. Now that we have the balanced equation, how many grams of MgO are needed to produce 264 grams of MgOH2? So, our given is 264 grams of MgOH2. So let's write that on the left. Give ourselves space. 264 grams MgOH2. We're going to go from grams of X to moles of X. That's our first conversion factor. So out of grams of X, the MgOH2, into moles of MgOH2. How many grams per 1 mole? Oh my goodness, we got to figure out the molar mass. Well, let's do that. Let's see. We've got magnesium and 2 OHs. Magnesium, looking in our periodic table, 24.3, and oxygen 16, hydrogen 1. So that means 24.3 plus 16 plus 1 is 17 times 2, 34. We add that up and we get an answer of 58.3. 58.3 grams per mole for magnesium hydroxide. So we'll use that right here, 58.3. And we have converted, canceling our units, we've converted out of the given grams to the number of moles of MgOH2. And now we do our mole-mole ratio. We get out of moles of MgOH2 into what the question is asking, MgO. So moles of MgO. And looking at our balanced chemical equation, 1 mole to 1 mole. 1 mole MgO produces 1 mole MgOH2. Now that we're in, and let's cancel our units. There we go. So now we've got a number of moles of MgOH2. We just did the mole ratio, moles of X to moles of Y, but now the question asks how many grams of MgO, not how many moles. So we have one last conversion out of moles of MgO to grams of MgO. So let's build our conversion factor. On the bottom, we have moles of MgO, and on the top we have grams of MgO. And it's how many grams per 1 mole MgO? Well, let's see. That would be Mg, 24.3 grams per mole, plus oxygen, 16.0, equals 40.3. 40.3 grams per mole. This is, of course, for MgO. Okay, so 40.3 grams per mole. And now we can cancel our units, moles of MgO, moles of MgO. And we have only grams of MgO left as units, which is what we wanted. That's great. So let's put an equal sign. Let's do the math. Take out our calculator, which is somewhere conveniently nearby. Huh. Oh well, let's use this one. 264. I can't believe I lost my calculator. 264. 264 divided by 58.3 equals times 40.3 times 40.3 equals, we got an answer, 182.49, la 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 la. So that's great. 3 sig figs, 182 grams of MgO, and we box our answer. Let's see if we can slide this over a little bit. Box our answer. There we go. And that is our calculation. Grams of X to moles of X to moles of Y to grams of Y. Grams to moles to moles to grams. Just like our roadmap shows, that is stoichiometry. We can only go from one substance X to Y with the mole ratio, where we have simple whole number ratios. Every substance has a molar mass. For that, we use the formula and the periodic table. That's stoichiometry. Have a beautiful day. Thank you, and see you later. No, that's not what I wanted. Wrong menu.